I'm going to talk for a few minutes about when to use law of sines versus law of cosines. So I'm not going to go real in depth on what those equations look like or just doing examples. There's other videos to do that. I just want to look at when do I use which one and when. So let's talk about the law of sines first. The law of sines we use anytime we have that related pairing. So let's say I'm just making up numbers. I'm not going to actually complete the problem, but if I know this is a side of 8 and this is, say, 100 degrees, and don't ever assume that I draw pictures to scale because I can't draw that well, but never assume pictures to scale. And let's say I have this side over here is 5, and I want to know any other part of this triangle. Well, because I have these two related items, the 100 degrees and the 8 are opposite one another, I can set up a law of sines to solve for any of those other pieces. So most likely I'd have to solve for this piece here first, this angle, which maybe I'll call angle B. Should use the uppercase because it's an angle. But I could put the sine over 100, sine of 100 over 8 equals sine B over 5, and then I could solve that for B, and again, you'll see videos on how to do that. Because we had that known pairing, sometimes it's that I can solve for that known pairing right away, and so maybe I know that this angle here is, we'll say 100 degrees again. This angle here, say, is 20 degrees, and I'll say that this side is 5. Well, right now it looks like I don't have any known pairings. The 20 is across from this side, I don't know what that is. 100 is across from this side, don't know what that is, and the 5 is across from this unknown angle. But I can very easily figure out that this angle right here would have to be 60 degrees because I know the angles of a triangle add up to 180. So once again, I can use law of sines. Generally, the law of sines is easier and faster. It's a faster equation. We can see that in the format of the equation. Remember, the law of sines, the difficulty we run into is there can be 0 solutions, there can be 1 solution, or there can be 2 solutions. And that has to do with the fact that when we were to solve this equation here, let's go ahead and just take this for a second, and we'll solve for B just so we can see what that looks like. And so if I take this and I were to work it out to solve, I would multiply the 5 over to the other side. The sine 100 over 8 is still there, and then we have the sine B. And then we take the inverse sine of this thing right here. And that's how we would solve for B. Remember, anytime we take the inverse sine always gives us an angle that is in the 4th quadrant between negative 90 and 0, or in the 1st quadrant between 0 and 90. So if I were to solve this right now, I'll go ahead and do it on a different screen. You won't be able to see. But it's going to give me just that one possibility. And so we have to be the ones to recognize that there is a second possibility still. So let me solve this real quick. And so when we solve that for B, we get 38 degrees approximately, just kind of ballparking here, 38 degrees. But then the question would be, well, was it really supposed to be the 38 degrees, or did the calculator just give me the one that was in the 1st quadrant? Sine, I know, is also positive in the 2nd quadrant, so what if I took that 38, put it into the 2nd quadrant? Well, I'd have approximately 142, call it B prime. That's also a possibility. But remember the picture of that one, that wasn't a possibility because we knew that B had to be smaller than 100, because side B is smaller than the 8. So because we knew how the ratios worked there, we were able to limit it to just the one solution. B would have to be 38. So the reason that law of sines is a little bit easier is the equation is just a little bit easier, but the reason it can be a little bit more difficult is the fact that we can end up with the 0, 1, or 2 solutions. Now, law of cosines has its own advantages. Law of cosines we have to use when we only know unrelated sides and angles. So for instance, if I had the sides known of 5, 8, and 10. I don't have any known pairings, so my only option here is to use the law of cosines. That's where the law of cosines is going to come into play. And so I'm going to just randomly kind of find one here, and we'll see what happens when I find this angle right here. I'll call this angle A. So we'll have the opposite, which is the 5. 5 squared equals, we have our 8 squared plus 10 squared. minus 2 times 8 times 10 cosine of unknown a. And so again, other videos will show you how to calculate this a, but what we should find is that this a is approximately, might just round 30 degrees. So we should be a little bit more precise, use some decimals. So I'm just going to do this real quickly because I don't really care about the math behind it. I just want to talk about the idea, how we get the triangle solved. So we have our angle 30 here, and then let's say I tried to find this angle up here. I'll call it angle B next. And now, because I feel like it, and law of sines, I said it's a little bit easier. Now I kind of have an open board. I could use the law of sines or the law of cosines. Law of sines is easier. Now I have those two related angles. I can use the law of sines. So I'll have sine of the 30 over the known opposite side of 5 equals the sine of b over the 10. And so we'd solve all of this, and the b that we'd find would be approximately, should be approximately 82 degrees. Again, ballparking, I have to round a little bit there. That's not what b should be. And the reason for that is I just used the law of sines. So remember, this is one of two possibilities. The other possibility was that it should be 98 degrees. And the 98 is correct in this case. So how would I have known that based on the sine? Well, I would have to solve the triangle completely. I'd go ahead and find C, and I'd take 180 minus the 82 minus the 30. And so we'd get 180 minus the 82 minus the 30. And the third side would have to be 68. And on this problem, there's nothing to tell us even that 68 is wrong, because if we look at those ratios to sides, we know that 10 is the largest side, b has to be the largest angle, even if we said the 82, which, remember, we're falsely saying it is, that is the largest. 60, which is the third angle here, the c, what I'm calling c across from 8, that second largest, that makes sense, and then the 30 are correct, but the 82 is not correct. We would have never seen it in the law of sines. With the law of cosines, because the cosine's inverse is, if it's a positive ratio, the inverse angle is going to be in the first quadrant. If it's negative ratio, it's in the second quadrant. Cosine, when it comes to law of cosines, the inverse cosine puts the angle right where it's supposed to be. There is no, it may have been 30, it may have been 180 minus 30, there's no question. Cosine is positive in the first and the fourth quadrant. Well, there's no way a triangle is going to have an angle more than 270 degrees. So I know that this A is the correct answer. That is 100% true, but I would have rather guaranteed I started off with the largest angle accounted for. I always want to start with that largest angle when I'm using the law of cosines. If I can find that largest angle, I've guaranteed there's no ambiguity, that is the one and only correct answer. And then if I use the law of sines later on, I don't have to worry about, is it the smaller, is it larger? Because it has to be the small. It can't be the obtuse angle. There can't be two angles larger than 90. So if I were to have used the law of cosines first to find this b, I would have found b to be the 98. Again, we knew that it's one or the other. We just didn't know which one of the two when we use the law of sines. But by using the law of cosines, we would find b to be 98. From there, I could use the law of cosines to find either A or C, does not matter, and I would guarantee that I have all the order right. So in general, what I like to say about this is, if we have to start with the law of cosines, we always want to start by finding the largest angle. The law of cosines, there is no ambiguous case. It isn't 0 or 1 or 2 solutions. It either works, we get one solution, or it doesn't work. There's no possibility of more than one. But sometimes the way that those problems are set up, we don't always have all three sides. And so sometimes it's just impossible to find that largest angle first using the law of cosines. So if we don't have that largest angle accounted for, if we can't guarantee that we have the largest angle taken care of, if we later use the law of sines, we want to make sure we find the smallest angle with that law of sines. So if we start a problem with the law of sines like we did up here, way up here, two possibilities is always on the table until we can guarantee ourselves that there is only that one. If we have that angle greater than 90, we guarantee that we only have that one. But if we start a problem with the law of cosines, the second we start the law of cosines, we'd like to find that largest angle first. That is not an option. When we go to use the law of sines, we want to make sure that we find that smallest angle first with the law of sines. If we follow those two steps, it doesn't actually matter. If I find the first angle with the law of cosines and then want to continue to use the law of cosines the rest of the way, go for it. It's going to give you the right answer. Law of sines, law of cosines should give you the same answer. Just law of sines, it gives you possibly sometimes two answers.